Hi everybody, I'm going to go over some of these homework problems and I'm just going to put 2 on this one video to make sure that this new app that I have is even working. So let's look at number 20 first. So that's the picture of f, and then they're telling you that this is the function right here of g of x, and with this new app I have new colors. So we're supposed to find g of 1. So if g of x equals this, then g of negative 1 would equal this. But you're not allowed to have the smaller number on top, so you're going to have to change that. So I flip it and put the negative 1 on the bottom, but then I have to add a negative sign. So basically what this is telling me is that I need the area that goes from negative 1 to 0. So that's this piece right here, from negative 1 to 0. And you can see that it's going to be this triangle right here. So you're just going to have a negative, and then you're going to do 1/2 base times height. So that negative came from this negative over here. So here's my negative, here's 1/2. So the base is 1, and my height is 2. So 1/2 times 1 is 1/2, and 1/2 times 2 is 1. So you get negative 1, and that was right here, choice B. So you might say, but it's negative area, and it's above the axes. It should be because we had to switch the integral. So it should really be positive, but because we switched the integral, that would make it negative. Sorry. Okay, let's go to number 100. So I'm going to erase. Whoops, I lost my picture. Hang on, I'm going to get that back. Okay, so now I just learned about one button that I'm not supposed to be touching. Okay, so here's our new graph. Sorry, this looks a bit blurry. So it's telling you that there is a tangent line at x equals 4, so that would be right over here. Whoops. Right there, there's my tangent line at x equals 4. And we're also being told that the function is this. And the question is, when does G have a point of inflection? So if you just forget the picture right now, what you should be thinking about is that, G has a point of inflection when G prime equals 0. Okay, so that's what we're trying to figure out. Also, you'd also have to have a sign change. Okay, so what we're looking for is when G double prime equals 0. Okay. So if this piece is G of x, then G prime of x equals d dx of this. Okay, so that's the second fundamental theorem of calculus, so therefore G prime of x just equals f of x. F of t, sorry. There should really be a dt in there. Okay. So, but we need G double prime. So G double prime of x would equal f prime of t. So this is the function right here of f, and we want f prime. So the question is, when is f prime equal to 0? So f prime is equal to 0 when there is a critical point on f. So you're looking for critical points, and one of them is definitely here when x equals 4. So this is a tricky question. Because actually right here, even though that's a cusp, the derivative would also equal 0 because it's going from increasing, here's the increasing, to decreasing. And whenever there's a change from increasing to decreasing, there has to be, or decreasing to increasing, there has to be a max or a min. So there's also a point of inflection at x equals 2. Whoa, crazy things are happening here. Okay, so remember, so when you have a function that goes from increase to decrease, or decrease to increase, there has to be a max or a min there. So we're not talking about taking the derivative again or anything like that. We're just looking for a max or a min. So that would be the answer for those. So I'm going to try and send this to you guys, and hopefully this has worked.